Yep, we're just going to hope it works. Okay, so did everybody find their notes or no? Who did not? Okay, I have a copy for you. Let me go ahead and pull this up. There we go. Let's get you some notes that you can take, and we will be ready to roll. Alright, so if you notice on your note sheet, like at the front, it says objective 3 up here, it has the 3 in the black bar. We have already done objective 3, so you should be at the second black bar, it says number 4. Okay, that's objective 4. So, what we're learning about today isn't necessarily a new concept per se. It's just a new word. Okay, there is a little bit of tweaks we're going to make, but it's basically going to be identical to how we calculate speed. Alright? So there's not a new process you're going to have to go through. There's just a couple of different terms that are different. Okay? So instead of speed, we're going to be talking about velocity. Okay? And the main difference with velocity and speed is what's written in blue here. It says it has direction. Okay? Velocity can also be positive or negative. Okay, so those are two of the big differences. Speed is always positive. Velocity could sometimes be negative, depending on what happens. Okay? And it has direction. So, with that being said, velocity is going to use displacement instead of distance. Other than that, everything is the exact same. We still have a triangle, but now this D right here stands for displacement instead of distance. And remember, distance is always greater. Okay, so it's going to include all of the loops and stuff. Displacement is just start to end. Okay? And that's why velocity has a direction, because displacement has a direction. You know, we talked about like, we move 3 meters to the east, or 3 meters left. Okay? That's the direction we're talking about. So, in our example here, okay, we still have miles per hour, which looks like speed, but now we have a direction tied to it, which shows us its velocity. Alright? Calculations are going to be the same. You just have velocity equals displacement divided by time instead of distance divided by time. But the triangle works the same, to where if you cover up the v, you're going to do v divided by t. If I cover up v, I'm going to do v multiplied by t. That part all works the same. Okay, is everybody okay with that? So what we're going to do is we're going to do examples to see how it works. And it's going to be very, very similar to speed. Is everybody good on this page? Did you write the definition down and stuff like that?
No.
Not yet? Okay, that's fine. Does the music bother anybody, or are we okay with that? Okay with it?
I have one.
Okay. Let me know when I can move on, okay? Alright, so let's go ahead and start by solving some examples. I'm just going to write them on the board, and you write them on your paper. Calculate displacement of the zombie cafeteria lady Doris. Oh, goodness. If she is traveling north at 4 meters per second and travels for 17 seconds. So, let's put our variables in. I have 4 meters per second north. Is that v, d, or t? That's going to be velocity, okay? Velocity and speed are the same as far as like these units go. With the direction, it's just velocity. So, velocity equals 4 meters per second. What about 17 seconds? Is that displacement or is that time? Time. So I'm going to have 17 seconds here. So I'm looking for displacement. If I think back to my triangle, D, V, T, I'm looking for D. What am I going to do with V and T?
Multiply.
Multiply, okay? So displacement is going to equal 4 meters per second times 17 seconds. If I multiply that, 68, yep, that's what I got too. 68, okay? Now for my answer in the last box, It's displacement, so we need a unit and we need a direction. Okay? So 68, what would my unit be? N. Okay, and I can look at that by I have two S's, so they cancel each other out, and all I'm left with is M. So 68 meters, which direction? North. Okay, and I just got that from the word problem up there. So 68 meters north. Okay, so y'all see how it's very similar to speed? Everything is very similar, just a few different words that we're going to use. Okay? Let's look at example 2. So, calculate Doris's velocity in meters per second if she travels 574 meters west and it takes her 14 minutes. Hint, it's telling us to change minutes to seconds. Okay? The reason why we want to do that is because it's asking for speed in meters per second. Okay? So, first of all, what variable is 574 meters west? What variable is that? V, D, or T? Distance, which is meters. Okay? So 574 meters tells us that it's going to be displacement. Alright? So 574 meters. We have 14 minutes, which we know is time. Okay? And how do we get minutes to seconds? How many seconds are in a minute? 60, so we're just going to multiply by 60. So I'm just going to do it down here a little. So 14 minutes is, well, we don't have to talk about that, just kidding, I don't want to get into that. 14 minutes times 60 is going to give us, what is it? 840, yes. So now we're seconds, and that's our time. Okay? How do I find V? Divide, okay? So back to our triangle. B, T, G. I cover it up. I'm going to do displacement divided by time. So 574 meters divided by our 840 seconds. .68. I don't walk in front of my camera. Okay, so now my answer is 0.68. Does anybody have a guess on the unit? Meters per second, okay? So these two cannot cancel out, the units, because they're not the same. So we have to keep them both in our answer. So meters per second, and then velocity always has a direction. Which direction are we going in our problem? West. So 0.68 meters per second west. That is our example number 2. Alright, we are going to skip example 3. Go ahead and go straight to example 4. And I'm going to give you a little bit of time to do it by yourself. And then we're going to go over as a class. But I want to see if you can do it by yourself first. I'm going to set a timer for 2 minutes. so it says, a kid runs to the cafeteria to see if they have any food left over. Then runs back home with 5 cans of tuna fish. The total distance was 500 meters, and it took 400 seconds. What is the velocity? So, and then it says in parentheses, pay close attention to the problem. So, velocity, does it include distance or does it include displacement? Velocity is displacement. Okay, so if I think about, I'm going to draw this diagram so you can get a visual. So here's this kid's house. He runs to the cafeteria and gets some tuna fish, and then he runs back home. What is his displacement? 0, because his start and end was the same. Okay, so that one tried to trick you, but remember, velocity is always displacement. Okay, it gives you a distance, but we don't care about distance in terms of velocity. Okay, so our displacement is going to be 0 because he started at home and ended at home. Alright, so this is actually going to be 0 meters. It did give us a time, 400 seconds. So I'm looking for V. What math do I do to solve for V? Divide, okay? So velocity is going to equal displacement divided by time. What's our answer? 0, okay? So in this case, our velocity is going to be 0 meters per second. We don't have a direction because it's 0, alright? So that one was a trick question. I want to see if anybody caught it. But velocity always uses displacement. Alright, let's turn our page over. And we're going to do problems where we calculate both the speed and the velocity. And that's going to help us really understand the difference between the two. Okay? So, eraser. Oh! So, it says, let's revisit the Dobby Harry problem over again. Notice there are times in the graphic below. Calculate your average speed and average velocity based on 0.4 in feet per second. What's the difference between the two? Okay? So, our example 1 is this. Hold on, let me figure out. I gotta get to the next slide. There we go. Okay, so it wants average speed. We're going to do speed over here, and it's going to want velocity over there on that end. Okay? It's in the black right here. I don't know if y'all can see that, but it matches your paper. Okay, so here's our diagram. Let's do speed first. Remember, speed is this triangle, and we're talking about distance, not displacement. So let's figure out what we can get from our diagram. A zombie hamster named Harry is loose in the school. That dude runs back and forth like shown in this diagram. Okay? So, we started here. We ran this distance in 20 seconds. He turned around, ran this distance in 15 seconds. Okay? So, what two variables can we get from this? Distance and time. Okay? So, our distance is going to be 100 plus 70. So our distance is 170 meters. Our time is 20 seconds plus 15 seconds. So we have 35 seconds. Everybody with me so far? Okay, so for speed we want total distance. So we're going to add up the total that you ran. Okay? Now how do I find for S? Divide. Okay, so I'm going to do 170 divided by 35 seconds. And you're going to get 4.86. What's my unit? Meters per second, okay? They don't cancel, so we have to keep them both. So that's my average speed. Speed does not have direction. Okay, so we don't need to include a direction on that one. We just need 4.6 meters per second. Now, We are going to use that exact same diagram, but this time find velocity, and you'll find that we get a different answer. Okay? What's the main difference? Like, how are we going to get different numbers? The distance and displacement. So with speed, we do distance, and that's the total amount that that dude covers. Okay? With velocity, we do displacement, and that's just going to be start to end. Do you remember how we figure out distances? You're going to subtract 100 minus 70. Okay? So, here's our triangle. We have B, T, and this is for displacement. So D is going to equal from start to end, it's going to be 100 minus 70. Our time is going to be the same, which was 35 seconds. And then our math will be the same as far as dividing. Okay, we still do D divided by T to find velocity. Alright, so we're going to do velocity equals 30 meters divided by 35 seconds. Goodness gracious. Okay, you divide those and you get 0.86 meters per second. We need a direction. Okay? So, start to end, which direction is this? Right. Okay? 0.86 meters per second, right? You could have put east if you wanted to. Just as long as you have some sort of direction with velocity. Okay, so big difference is our distance and displacement were not the same, but everything else was. Okay, and then another big difference, we have meters per second here, and on velocity we still have meters per second, but a direction as well. Okay, so those are the big takeaways. We're going to do one more example, that exact same situation, just a different diagram. I'm also going to switch markers so that we can see it a little bit better, hopefully. Alright, so average speed goes first. As that dude runs around the corner and away from Zombie Hamster Harry, he sees a zombie snake named Sid. What's going on in the school? He takes off running like below. Okay? So for average speed, what is my D stand for? Distance. Okay? So to find distance, I'm going to add 115 and 55. What does that get me? I can't do math. 170? Possibly. No, it's going to be 170 because... Yeah, okay, yeah. So that is distance. Time, we're going to add it to seconds, so we're going to get 35 again. 25 plus 10. And then how do I solve for speed? Distance divided by time. Okay, I know this is getting repetitive, but if we can get it down, that'll be great. 170 divided by 35, it's the same as the one above. 4.86 meters per second. Okay, now we're doing velocity. The big difference is displacement. Okay, so we just want start to end, we don't want the total distance. Okay? So for velocity, our D is displacement, and we subtract this time. 115 minus 55 is going to get us 50. Our time is still the same, that doesn't change. And then we divide again. V equals D divided by T. 1.7. And this was west or left. Okay? Velocity has direction, so we got to include that in our unit. Okay? Is it making sense? You think y'all can handle the difference between speed and velocity? Okay, let me show you your Canvas assignment for today. I can't see over there. Yes?
Can I have the knife?
Microwave. There's a box back there. Okay, Canvas. Alright, so on Canvas, your assignment is not just about velocity today. So let me get my student view on. You're doing 7.3B assignment, and it's going to cover distance, displacement, speed, and velocity. So it's going to ask you questions about all four of those topics. Make sure you pay attention to wording. Okay? So let me just show you a few examples here. Alright, so a truck moves from A to D along the path as shown. What's the truck's distance and displacement? So this one, it wants both of them. So this would add it up, would be your distance. From A to D would be your displacement, start to end. Okay? Each box is 1. Let me find another one. That's asking for the formula for velocity. Okay, this one, a motorcycle moves from A to D along the path as shown below in 3 seconds. What's the speed of the motorcycle? So in this one, you have your time, you need to find distance. So that's when you would add all of these up. There's going to be an identical motorcycle question. Let me see. Okay, this is an identical motorcycle question, but now it wants velocity. So you're not going to add up A to D. You're going to go straight line from A to D, so it would be 3 for your displacement. Okay? So don't let these questions trick you is what I'm trying to show you. Read them, make sure you understand what you're trying to solve for, and always remember speed is total distance, velocity is just displacement. Okay? Think I can handle that? Okay? This is on Canvas 7.3B. Get it turned in today for me, please, and you're good to go after that. Does anybody have any questions? Okay, if you do need help on the assignment, don't be afraid to ask. Okay, I'll come over there and help you out. Great.